Hi, hello. Dear students, I am Dr. Rajiv Sapre and this is lecture number 46 about metric topology. We are actually discussing about sequences in metric space. In the previous lecture, we have given the definition of a convergent sequence. I will again repeat what is meant by sequence is convergent. So suppose you have a metric space x comma d. Okay, and if xn is a sequence, xn is sequence in x. What you mean by sequence xn is converging to x. This is how the notation xn converges to x. What was the definition? For epsilon greater than 0, for any epsilon greater than 0, there exists k belonging to n such that distance between xn and x is less than epsilon for all n greater than or equal to k. This was the definition, and we have seen certain examples about sequences in R. We have seen that if you take R comma D as your metric space, usual metric space, then the sequence 1 upon n tends to 0. Then constant sequence, suppose I take constant sequence, right? Suppose it is say C, then you know that this C converges to C. Then also we have seen one example of a non-convergent sequence. The sequence that we took was n squared. Now when you take n square, the terms of the sequence are 1, 4, 9, 16 and so on. You can see this is a range set of the sequence. This is not bounded. म्हणजेच काय झालं, हा सिक्वेन्स बाउंडेड नाही. आणि जेव्हा सिक्वेन्स बाउंडेड नसतो त्यावेळी तो कॉन्व्हर्जंट नसतो, कारण आपल्याकडे एक रिझल्ट आहे. वी विल प्रूव्ह इट आफ्टरवर्ड्स. एव्हरी कॉन्व्हर्जंट सिक्वेन्स इज बाउंडेड. सो व्हेन सिक्वेन्स इज कॉन्व्हर्जंट इट implies it is bounded. What will be the contrapositive of this statement? When sequence is not bounded, it is not convergent. So that result we can use. See, all the results that we prove, we should use them to solve the problems. We are not just reading or doing those results because they are asked in papers and we have to write answers corresponding to that. How it will be used? You have studied already logic. In that you know whenever you take implication P implies Q, then it is logically equivalent to its contrapositive statement. Not Q implies not P. So that you can use. When sequence is convergent, it is bounded. Its contrapositive is when sequence is not bounded, it is not convergent. Now this sequence is not bounded because it is range set is not bounded. Like this we have to think. Now in this lecture we will again consider some more examples of the convergent sequences, and let us try to prove that a particular sequence is convergent or not. That we will try to prove. Okay. So the example that now we will take will be sequences in R2, right? So we will now try to say R2, and on that Euclidean metric you define R2D. You know the definition of Euclidean metric. It is something like this. Suppose this is your x1, x2, 1 point, and another point is say y1, y2. That means dxy, right? This is your x, suppose, and this is your y. Then what was the definition? Euclidean topology मध्ये, Euclidean metric मध्ये, not topology etc. Sorry, this I will write in proper way. Euclidean distance जे आपण म्हणतो ते कसं असतं, त्याची डेफिनेशन काय असते? इट इज x1 minus y1 bracket squared plus x2 minus y2 bracket squared, and with respect to this distance function, this is a topology, this is a metric space. This is already we have put. Okay, so now we will take a sequence xn, okay, where the definition of that sequence, the terms, nth term of that sequence, general term, is what? 1 upon n, comma 3n upon 4 plus 5n. 3n upon 4 plus 5n, right? This is the sequence. See, what will be the terms of this sequence when you check? Here, this will be, n is from natural number set. So your x1 will be 1 upon 1, comma, 3 upon, n is 1, na? So 4 plus 5 into 1, that means 3 upon 9. Then next term, that means x2, it will be what? 1 upon 2, comma, now when you put n is 2, it is 6 upon 4 plus 5 into 2. 5 into 2 is 10 plus 4, so it is 14. Like this. So you can list the terms of that sequence. They are infinite, so you cannot write all the terms. But we can get the sense. We can get the sense. This 1 upon n, you always know that this 1 upon n, this sequence converges to 0. And what will be this 3n upon 4 plus 5n? What you can do is you take limit of this quantity as n tends to infinity. ती जी nth term आहे sequence ची xn, if you calculate limit of that term as n tends to infinity, you will get the point where the sequence converges. So you know 1 upon n tends to 0. Definitely we know this. When n tends to infinity, 1 upon n tends to 0 means when n tends to infinity. What about this 3n upon 4 plus 5n? You can see here, if I divide by n, this will be numerator 3 and this will be 4 upon n plus 5. Now 4 upon n tends to infinity, 4 upon n tends to 0 when n tends to infinity. So when this n tends to infinity, this term 3n upon 4 plus 5n will tend to 3 by 5. So what I can say, this sequence tends to 0, 3 by 5. Can we prove this? Analytically, can you prove this? This is by using calculus concept, limit n tending to infinity. But by epsilon k definition, can we prove this? This is very important. That we will try to do. मग त्याच्यामध्ये काय असते थीम आपली की यू आर गिव्हन epsilon is given, you have to find k which satisfies that property, that for all n greater than or equal to k, difference between or distance between nth term and the point to which the sequence converges, that becomes less than epsilon. That we have to prove. So we will proceed here. See, I will erase all this, we don't need that. See, to prove that, sequence this 1 upon n, comma 3n upon 4 plus 5n tends to 0, 3 by 5. This is what I have to prove. In R2, naturally, this is sequence in R2, so it will converge to point in R2. So let epsilon greater than 0 be given. Let epsilon greater than 0 be given. Okay, I will erase this part. It is not needed now. This was the definition of Euclidean distance, etc. So this part I will delete. Okay, so now let epsilon greater than 0 be given, any real number. Okay, and now consider distance between. So I will say consider distance between what? That term of the sequence, means general term 1 by n, comma 3n upon 4 plus 5n, comma 0, 3 by 5. I have to show that this is less than epsilon, right? For all n greater than or equal to k, such k exists. You have to, epsilon is always given. We have not to find epsilon. What we have to find is k. So what you do, first you calculate distance between these two. Now by Euclidean distance formula, what will be this? You know the formula. I have written it here. It was what? Root of difference between x coordinates, that means x1 minus y1 bracket squared plus x2 minus y2 bracket squared. So here it will be root of 1 upon n minus 0 bracket squared plus, it will be now difference between y coordinate, so it will be 3n upon 4 plus 5n minus 3 by 5 bracket squared. So now you can see here that this is nothing but root of, this is 1 upon n minus 0, it is 1 upon n, square of that is 1 upon n squared, and plus, now here it will be cross multiply, we have to do 5 into 3, that is 15n, minus this now 4 plus 5n into 3, so it will be what, minus 12 minus 15n, and then divided by 5 into bracket 4 plus 5n, 5 into bracket 4 plus 5n, and square of this, right, square of all this. So if you continue it here, it will be root of, this is 1 upon n square, now here it will be plus, this 15n minus 15n will get cancelled. Is it right? I think I am doing correctly or no? See, 3n into 5 is 15n minus this is what, 12. Is it right? It is 12. It should not be, okay, this is 3 by 5. We are proving it is converging to 3 by 5, correct? It's not 1 by 5. 3 by 5. Limit of this term 3n upon 4 plus 5n, when you write, it converges to what? 3 by 5, correct? So we are right. So this is 15n minus 15n will be cancelled, and this will be what? Minus 12 upon 5 plus 4. So it will be what I can write here? This will be 12 square, because minus 12 is square, so this will be 12 squared. These are calculations that we should take care. Upon what? Square of this. So this will be 25 into bracket 4 plus 5n bracket square. This is what I get. Now you can write this as, okay, this will be equal to root of what? 12 square upon 25. So it will be 1 by n squared plus 12 squared divided by 25 and divided by 4 plus 5n square. So instead what we can do is we can take divide by 5. So this will be, I will take 5 outside, right? 5 I will take outside. So inside the bracket it will be 4 by 5 plus n bracket square, and 5 I am taking outside the square bracket, so it will be 5 squared. So now this is same as, this is 1 upon n squared, sorry. So this is equal to now root of 1 upon n squared plus, now this is what? 12 squared upon 25 into this 25. So this is what? It is now, I can write this as 12 upon 25 bracket squared divided by this 4 by 5 plus n bracket squared. This is what I will get. Okay. Now this I can write less than or equal to root of 1 upon n squared plus 1 upon this 4 by 5. I will erase this. I will write it in a different location so that you can be clear about the things. Okay. So I will write it here. This term we have come up to this. Okay. Now what I can do is this I can write less than or equal to root in the root sign 1 upon n squared plus 1 upon 4 by 5 plus n bracket squared. Why I can write this? I am replacing 12 by 25 bracket squared, I am replacing by 1. Now I know that 12 by 25 bracket squared is less than 1 because 12 is less than 25. So this numerator is less than 1. This quantity I am comparing with 1 upon 4 by 5 plus n bracket square. So this is something which is less than 1. So definitely whole this quantity is less than 1 upon 4 by 5 plus n square. So I am very legally I am writing this. Now again what I can do is this is less than or equal to 1 upon n squared is already there in the root sign. Okay, and now instead of this 4 by 5 plus n bracket squared, right, I can write this again as 1 upon n squared, and this instead of 4 by 5 plus n squared I am writing just 1 upon n squared. This is legal again because why? 4 by 5 plus n squared is greater than n squared. So here numerator is greater than n squared, so whole quantity is less than 1 upon n squared. So now this is root of 2 upon n squared. That means it is root 2 upon n. Now if this is less than epsilon, see, we have got this whole thing, distance between 1 upon n comma 3n upon 4 plus 5n and 0 3 comma 5 is less than root 2 upon n, and if this is less than epsilon, right, if we choose n as greater than what? Greater than what? So this root 2 upon n less than epsilon, याचाच अर्थ काय होतो? root 2 upon epsilon is less than n, right? So n is greater than root 2 upon epsilon. Root 2 upon epsilon. So now as epsilon is given to you, you can substitute it here, right? Root 2 upon epsilon, epsilon value is known to you. So if I choose n greater than root 2 upon epsilon, I will get this distance as less than epsilon. We have proved that. So I will erase this part now. So what I know now? What I know now, I will write it here. So this distance between 1 upon n and comma 3n upon 4 plus 5n and 0 comma 3 by 5 is less than epsilon when n is greater than root 2 upon epsilon. Now always we know that epsilon is given, so I can put root 2 upon epsilon here, and what I can do is choose n0 as we can say it is integer value of root 2 upon epsilon, and to make it safe plus 1 u2, right? Now when n is greater than this n0, this quantity is itself greater than root 2 upon epsilon because I am taking integral part of root 2 by epsilon plus 1. So this is greater than root 2 upon epsilon, and so what I can say, for all n greater than or equal to n0, distance between this 1 upon n comma 3n upon 4 plus 5n and 0 comma 3 by 5 will be less than epsilon. For all n greater than or equal to n0, where n0 is this much, we have proved that distance between the general term of the sequence and 0 comma 3 by 5 is less than epsilon. So what does this mean? This sequence converges to 0 comma 3 by 5. So see how the things are done. How you choose epsilon, how you choose n0. Epsilon is not to be chosen, epsilon is given, sorry. But how you choose n0, you should go through, and such practice you should do of solving such problems. It will be very simple. If you practice, the things are simple. So first you calculate distance, make it less than epsilon. From that try to get what is n0. Right? You have to estimate the value of n0. क्या n0th टर्म पासून पुढच्या सर्व टर्म्स कशा असणार आहेत की जनरल टर्म आणि ते ज्या पॉइंटला इथे आता या सिक्वेन्स मध्ये सिक्वेन्स वी हॅव टू प्रूव्ह कॉन्व्हर्ज टू 0,3/5. त्यामुळे जनरल टर्म आणि 0,3/5 ह्याच्यातील डिस्टन्स लेस दॅन एप्सिलॉन आहे फॉर ऑल n ग्रेटर दॅन इक्वल टू n0 वेअर n0 इज दिस मच. सो वी हॅव मेड or we have seen that this particular definition satisfies the definition of convergence of the sequence. This particular calculation satisfies the definition of convergence of the sequence. So I can now finally say that 1 upon n comma, so what is the final conclusion out of all this discussion? Final conclusion is this sequence 1 upon n comma 3n upon 4 plus 5n. This sequence converges to 0,3/5 because for any given epsilon greater than 0 there exists n0, right, which is equal to integral part of root 2 upon epsilon plus 1 such that for all n greater than or equal to n0, distance between this 1 upon n comma 3n upon 4 plus 5n comma 0 to 3/5. This distance is less than epsilon. This I will erase. It is not needed now actually. Okay, so this is how you can prove. These are nature of the proofs. Means are like this. They are somewhat lengthy. Calculation is involved. You should be good at calculations, but still you can easily see that the things are not difficult. Instead of this particular sequence, any sequence can be given. Now this was the sequence in R2. Sequence in R2 म्हणजे कसा असतो? See, now all these things are we have done. So I will erase all these things. And how is the sequence in R2? See, sequence in R2 means, you know, ordered pair. So sequence in R2 is ordered sequence xn comma yn, ordered pair, where xn is sequence in R, yn is sequence in R. xn and yn, we can say xn and yn are sequences in R. Are sequences in R, right? And we are considering Euclidean distance. We are considering usual Euclidean metric on R2. Euclidean metric on R2. We can prove one result that sequence xn and yn is converging. Xn comma yn is the sequences in R2. It is converging to x comma y if and only if sequence xn converges to x and sequence yn converges to y in R. But that we have not yet proved. If it is proved, easily we can do this result, because xn आपला sequence काय दिलेला होता? 1 upon n. In this particular problem, xn was 1 upon n and yn was 3n upon 4 plus 5n. Now this sequence tends to 0. This sequence tends to 3/5. So totally xn comma yn converges to 0,3/5. So effectively we are using this result, but we have not yet proved. So we did it by conventional technique, epsilon n0 technique. But if you understand the theorems properly, if you know the results properly, you can use those results effectively to prove certain results in mathematics. So that requires very sound knowledge of all the results about that topic, about the topic that you are learning. हे आपल्याला चांगलं लक्षात ठेवलं पाहिजे की मला जे काही मी टॉपिक शिकतो आहे त्या संदर्भातले सर्व रिझल्ट्स मला माहिती पाहिजे. Then I can use those results. Results, as I told in one of the previous lectures, the results we are proving, results we are studying, not because they are asked in the papers and we have to write their answers. We are studying them to apply to solve certain problems. The applications of these results are very important. That is why results are studied. That is why results are taught. That is why many theorems are to be studied, right? So I hope you understand how this problem was done, and many other things also I told you in this particular lecture. Thank you. We will continue study of sequences in next lecture. Thank you.